Transformations on the coordinate plane. There are four types of transformations that the section is going to cover. Translation is one of them. That's the slide. Reflection, think of that as like a mirror, see your reflection. Rotation is just like a spin, and it's always counterclockwise. And the last one is dilation, which means to make bigger or smaller. And also to know about a dilation is that there's a scale factor, which is represented as K, and K is always positive, and it's never equal to 1. So you cannot have a negative number, and you cannot have 1. It can also not be equal to 0, so make sure you add that in there as well. Okay, so I'm going to do an example of each one of these, and then give you the important information as far as the math goes. I'm going to go through the translation first, which was the slide. The trick to a translation is to add the order pair, add whatever number you're given to the order pairs. So the example is to translate the figure 3 units to the right and 2 units down. And then it gives you 4 ordered pairs, which form some type of quadrilateral on a graph. So it says to add the number to the ordered pairs. 3 units to the right, we're talking about left and right, so that's going to be the x value. And then 2 units down, talking about up and down, that's going to be the y value. So you're going to add 3 to the right's a positive direction. 2 units down is a negative direction, so we're going to actually subtract 2 from our y values. So you can do that to each of your ordered pairs. Okay, so I just rewrote my new ordered pairs with the addition and subtraction in it. These little apostrophes that are with each of the letters means prime, so that actually means our second figure. So then we just go ahead and finish the math, and then we'll have our new ordered pairs. So then our new figure, after being moved 3 units to the right and 2 units down, has the order pairs of -3, -2, -1, 1, 2, 1, and 0, -2. Dilation is the second one. Dilation, the trick for that is going to multiply the scale factor by the x and the y values. The example says to dilate the figure with a scale factor of 3. So then we're given 3 ordered pairs. And then you're just going to take each of those numbers and multiply them all by 3. Now remember, your scale factor can be anything from a fraction to a whole number. If it's a fraction, our figure is going to be smaller. If it's a whole number, then our figure is going to be larger. So in this case, if we were to graph it, it would be larger. So I can squeeze this up just a little bit. Let's see if I can fix this. There we go. Okay. Finish the math. And those are in the ordered pairs for the second figure. Okay, the last two are reflection and rotation. Reflection, there's no easy way to do this other than to memorize what happens to your x and y order pairs. If we reflect over the x-axis, our y changes to a negative, or the opposite. If we change over the y-axis, then our x becomes the opposite. So in this case, we're going to reflect over the x-axis. So that means all of our y's change. X stays the same, and then we're going to change our y to the opposite sign of whatever it is. So in the first one, it's 2, so we're going to change it to -2. Q prime becomes 4, -4, and R prime becomes 2, +3. And that's all you would do for that one. And the last one is a rotation. For rotation, it's just a trick of knowing what to do with your ordered pairs again, just as it was with reflection. The example is to rotate counterclockwise 90 degrees around the origin, and we're given these 3 ordered pairs. So for 90 degrees, we're going to change the x and the y, and then we're going to make our y the opposite, just like we did with reflection. So J is 0, 0, and that one actually doesn't change. K prime, -2 is our x, so we're going to change that and put it in our y spot. And then our y, we're going to take the opposite of that. So -5 becomes +5. And then L, our -4 is our x. And then 5, we take the opposite of that, and that becomes -5. So if we were to graph the old and the new, then it should show that it was rotated counterclockwise around the origin.